Welcome back, everybody. So for today's problem, we're looking for what is the sum of the numbers in a 10 by 10 multiplication table. So we want to take all of the numbers that you see here in the multiplication table, and we want to add them up. You know, that seems like a really big pain to me. So there's going to be 100 of those numbers if we don't count the zeros. And unlike Gauss's trick, it's not just going to be the sum of the numbers from 1 to 100. There's all kinds of different numbers thrown in there. So that's a real pain in the butt. I don't want to do it. There's got to be a better way to do it than just to sit here all day and sum these things up. I really don't want to do it. So what I've done is I brought in my consultant, Kyle.
Hey guys.
And he's going to help me out because I'm sure he studied those last few videos that we did really hard, and I'm sure he's got a couple of ideas on how we can proceed here. So what do you think, Kyle? What are you seeing when you look at this? I'm stuck.
Well, when you look at it from the normal view, it looks really hard.
Yeah, there's all these numbers in there. I don't know what to do. I don't know where to start.
But instead of doing it all at one time, let's do it one row by one row.
Oh, so you want to break it down and do it one row at a time and then just add up all those rows.
Exactly.
Well, that seems like a good idea. Let's start with
especially since the first row is the sum from 1 to 10.
Oh, that would just be the sum of the numbers from 1 to 10. So we know how to do that, right? So let's just start off with the first row. Let's just get started. So what we have for the first row is we've got 1 plus 2 plus 3 all the way up
10
plus 8 plus 9 plus 10. So we actually just know straight away how to do that, right? Using Gauss's trick. So if we remember the formula, we know the formula for the sum of the numbers from 1 to n
is n times n plus 1 over 2.
n times n plus 1 over 2. Now if you don't remember that, just write this forwards, write it backwards.
And then you can see that.
And then add them up, you'll get the same sum and just do what we did last time. But we're going to use the formula since we remember that. So what we're going to have is 10 times 11
over 2
divided by 2.
And we have a common factor of 2 with the 10 and the 2, so we can just cancel that out, giving us 5 times 11, which is 55.
Yeah, remember, we're always going to have consecutive integers, so one of them will be even, so we can use that even one to cancel out the 2. 5 times 11?
55.
That gives us 55. So I'm going to write that in a special way. I'm actually going to write that as 1 times 55.
Why would you do that?
And we're just going to leave it like that. I'll show you why I'm going to do that later. All right, so we got the sum of the numbers for the first row of the multiplication table. So now, what do we want to do?
Now we just take the second row.
All right, let's look at the second row. Well, that's just the sum of the first 10 even numbers, right? We've actually also done that problem in the previous video, so I like the way this is going. This was a good idea. So let's just do that. We've actually done this problem, but let's just review it. So we've got 2 plus 4 plus 6 all the way up
10
to 20.
and 20.
So I want to write that.
The common factor of 2.
Yeah, let's write that so we can see that. Let's write that as 1 times 2 plus 2 times 2 plus 3 times 2
plus 4 times 2 all the way
plus
2 times 10. 10 times 2.
8 times 2 plus 9 times 2 plus 10 times 2. And now we can clearly see we've got a common factor of 2. So let's factor it out. And now, what do we have?
2.
We have 2 times the sum of the numbers from 1 to 10.
So
Well, we know now that that's 55.
55 times 2.
So we'll just write that as 2 times 55.
Oh, and then once we get down more, we'll have 1 times 55, 2 times 55.
Yeah, so let's box
So
that in.
my guesstimate for the next problem when we go to the 3 row is that it's going to end up as 3 times 55.
Right, so let's look at the 3 row. So we've actually got the multiples of 3 now, so that's going to be 3, 6, 9, 12, 15, all the way up through 30. So let's go work on that one. So we've got 3 plus 6 plus 9 all the way up to 30. So let's rewrite that. It's 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 8 plus 3 times 9.
Plus 3 times 10.
And now we can clearly see we've got a common factor of 3. So let's factor that out. And what do I have? I have 3 times the sum of the numbers from 1 to 10. So we're probably getting really good at knowing what the sum of the numbers is from 1 to 10 now.
55.
So that's going to be 3 times 55.
I see a pattern here.
Starting to see a pattern, right? So our pattern is whatever table that we're on in the multiplication table. So next would be the 4s. We can see that those will just be the multiples of 4. So we'll be able to factor out the 4, and we'll have 4 times the sum of the numbers from 1 to 10, right? When we go to 5, that'll give us the multiples of 5. So we can actually factor out the common 5, and we'll have 5 times the sum of the numbers from 1 to 10.
Which is 55.
Yep. And then
Then
we'll
you
have
go to 6, it's going to be 6 times 55.
same thing. We'll factor out the 6. We'll have 6 times 55.
And then 7, same thing, factor out the 7, it's going to be 55. 7 times 55.
Yep, and we'll just keep doing that until we finally get to the 10, where we factor out the 10. 10 times the sum of the numbers from 1 to 10, or 10 times 55. So let's go ahead and do it. So once we get all of those, then we just need to add up the sums from each of those rows, right?
Because
So we
you
have,
can factor out the 55.
so we'll have 1 times 55 plus 2 times 55 plus 3 times 55 plus 4 times 55 plus 5 times 55 plus 6 times 55 plus 7 times 55
Plus 8 times 55. Plus 9 times 55. Plus 10 times 55.
Okay, so that's our sum. So we've taken the sum from each of those first 10 rows now, where we factored out the common factor each time, and we were left with the sum of the numbers from 1 to 10, which evaluated in every time to be 55. So now what do you see? This is still going to be kind of a pain to add up all this stuff.
I see a factor of 55.
Ooh, there's a common factor of 55 in each one of those terms.
So you can write
So
55
let's factor it out.
times parentheses 1 plus 2 plus 3 all the way to 10. And now we know that the sum from 1 to 10 is 55. So we have 55 times 55.
And we just get back our sum of the numbers from 1 to 10 one more time, and that's going to be 55 again. So now I've got 55 times 55, or 55 squared. So the sum of the numbers in the multiplication table from 1 to 10 is just 55 squared. All right, so the problem that we need to solve now is just calculate what 55 squared is. So I'll just calculate that out. 55 times 55. So we've got 25, carry the 2. 25 plus 2 is 27. So then second row, I've got 25, carry the 2, 25, I've got 27. 5, 12, and I get 3,025. So there's the answer. So the sum of all the numbers in the multiplication table, a 10 by 10 multiplication table, is 3,025.
There's actually a trick where squares ending in 5.
You got a trick for squares ending in 5? Ooh, I want to hear it. I like saving work whenever possible.
Okay, so whenever you have a square that's ending in 5, it ends in 25.
So it always is going to end in 25, so we can just write that down, okay?
And then you take the tens digit, which in this current problem is 5. So then you multiply that by the next integer higher than that.
Okay. So that would be 5 times 6.
Which is
30.
30. And then it's 3025, which is 3025, which is what we got here.
Just write that in front of the 25, and we get 3025. Sure enough, it's the same. Well, that's pretty cool.
Let's try 35 squared.
Yeah, let's just try one more example just to convince ourselves that this is going to work for any square ending in 5. So let's try 35 times 35. So let me just do that manually here. I get 25, carry the 2. 175, carry the 0. 15, carry the 1. And the 10.
And now you can see that it ends in 25.
So I get 1,225, so it does end in 25 like it should. Let's try the trick. So we'll write down the 25, our number, take the number that's not including the ones place, so in this case that's 3, multiply it by the next integer higher than 3, that's 3 times 4, and that's 12.
And then it's
1225.
1,225, which is what we got here.
So they match up, so that's pretty cool, Kyle. So that will save us a lot of work when we're trying to multiply squares ending in 5. So I really like this problem. So everything just kind of fell apart like dominoes once we knocked over that first one. We were able to reduce every problem to factoring out the multiple of that multiplication row. And then it reduced at that point to the sum of the numbers from 1 to 10 times the factor in the multiplication table row. And then once we got that, we were able to actually factor out that 55, which was the sum of the numbers from 1 to 10. And that left us with another sum of the numbers from 1 to 10. And so we ended up with 55 squared, which, using the nice square ending in 5 trick, we can immediately get to be 3025. So actually, just using 2 very simple principles that we covered in the last videos, the Gauss's trick for the sum of the numbers from 1 to n, and the distributive principle, we were able to solve a much more complicated problem. And it's a problem that actually, using all of those various techniques, it's a problem that we can do in our head in probably less than a minute once you got it down. So that's pretty cool. That's pretty amazing. So I hope you guys enjoyed this one. We'll see you again next time.
Make sure you subscribe.
Yeah, we'll solve some more tough problems.